we are taking a rocket, and in that rocket we are assuming that this rocket is moving in space and there is no external force. All the external force on the rocket are zero, right? And we are now going to calculate the how much will be the velocity at what time. Okay. And we are also going to calculate the force, and there will be also another case where there will be some external force. So same condition in that we will take the same condition where there will be rocket moving, but that will be moving in the gravitational field. So we will assume, let's say that mg ejecting. So that for that case we will have separate video. So let's start it. So here I am taking a rocket that is moving at any time t. Okay, this is an instant where that rocket is having a mass m and the velocity of the rocket is v, and the total force on the rocket are zero, right? So if a total force on the rocket are zero, it means the momentum of rocket will be conserved, right? So momentum will be conserved. Now what is happening, for going up, this rocket is ejecting some fuel at the some rate. So I am assuming that in the dt time it has like given out some dm mass, right? And also because it is giving dm mass out with a relative velocity vr. vr is the vr is the relative velocity of fuel that is ejected with respect to rocket, right? So now that is VR, and because it is giving out some fuel, that's why the velocity will become v plus dv, right? And the mass will also decrease. So now we need to calculate. So can we apply the conservation of momentum? Yes, we can apply the conservation of momentum. So by conservation of momentum, we can write down that P initial will be equals to P final, right? So what is P initial? P initial is m into v, that will be equals to final momentum. Now for calculating final momentum, there are two parts. One is this rocket. So rocket is having m minus dm mass, because dm fuel is ejected from it, and it is having a velocity v plus dv, right? And this fuel is going to have dm mass and is having a velocity. We do not know the velocity of this fuel. So for before that, we will need to calculate the velocity of fuel. So see that velocity of a fuel is given with respect to the rocket. So we can write down velocity of rocket, velocity of fuel with respect to rocket is equals to velocity of fuel minus velocity of rocket, and the velocity of rocket is v plus dv. Okay, so velocity of fuel can be written down as v relative plus v plus dv. Okay, so now if we put the value, so we can write down v fuel over here, v relative plus v plus dv. Now if we just open the or solve it, so we can write down m into v, and in the right side we can write down m into v and m into dv, and then next will be minus dm into v minus dm into dv, and then if we open this, so that will be dm into vr plus dm into v and dm into dv. Okay, Now here we are going to have this. There are two terms dm into dv, dm into dv. Although they are very small, we can neglect them or otherwise we can cancel out them. And here we are going to have dm into v, that is negative, and dm into v, that is positive. So that will also be cancelled out, and m into v also be cancelled out. So we have m into dv, we have 0 is equals to m into dv plus dm into vr, right? So from here we can write down that if we take that side, so m into dv is equals to minus of dm into vr. If we just divide by dt, we can write down this m into dv by dt, that is m into a, mass into acceleration, is equals to minus vr into dm by dt. Okay. Now what is m into a? On the, if you see this rocket, so rocket is moving with velocity v and its velocity has been changed to v plus dv. So it means it is experiencing some force, and that is the force. Okay, right? So we can write down ma we can write down f. So f will be equals to, and f will be equals to minus vr and dm by dt, that is the rate of ejection of mass. So sometimes it is written down by dm by dt, and sometimes it is written down by r. So that is the force that will be experienced by the rocket in moving upward, in upward direction, right? So this force is known as a thrust force. Okay. So now here we can also note down the direction. So here Ft is equals to minus of Vr into dm by dt. So in the case of in the case where fuel is ejected, so the thrust force will be acting in the opposite direction of relative velocity. So here we can see relative velocity is in downward direction. That's why the force that is acting on the rocket will be in upward direction. Okay. So let's do one question on that. So we are taking an example. So where one rocket is there, and rocket is there, and the total mass of rocket is 20,000 kg. Now it can eject the fuel at a rate of 100 kilogram per second. Okay. So now they have asked what should be the relative velocity of fuel, that so that it can balance its gravitational force. Okay. So let's do it. So here we have some values. Mass is given to us, and dm by dt is given to us. At some instant, the mass is given. So if mass is given, what will be the force? What will be the gravitational force that will be acting? So the force, gravitational force will be acting how much? 2000 kg. So 20,000 kg. So gravitational force will become m into g. So that will be 2 into 10 to the power 5 newtons. Okay, so who is going to balance it? The thrust force is going to balance it. Okay, so it means the F thrust should be equal to F gravitational. Now what is F thrust? F thrust is V relative into dm by dt. So V relative into dm by dt will be equal to F gravitational. From here we can write down V relative. V relative will be F gravitational divided by dm by dt. Now what is F gravitational? F gravitational is 2 into 10 to the power 5 divided by dm by dt. What is dm by dt? That is 100. It means the V relative should be equals to, so if you cancel out, so it will be 2000 meter per second, or we can say 2 kilometer per second. Okay, that should be the velocity of ejected fuel for just keeping it balanced with the gravitational force. Like this, we can do the calculation for the these kinds of examples, and the next kind of example we are going to see in the next video. So now in this video we have covered how for the variable mass system we can calculate the thrust force, and even if we want to integrate, we can also calculate the velocity at any time t, that we are going to do in the our next video. So let's end over here. Thank you very much. Now you can try the questions that are on this topic.